Hello everyone, welcome to Science Lesson. Today we are going to learn grade 11, lesson number 8, heat changes associated with chemical reaction. I am Rashida Farvin. Remember what we studied in grade 10 about chemical change? One of the following can happen during a chemical reaction. One is a formation of new substances by the combination of two or more substances can occur. And the second one, turning one substances into two or more substances. And the third one, reorganization of initial substance to form a new substance. For example, when you heat limestone, remember what happens. And also when burning of firewood, just check the reaction take place during these two instances. And in this lesson, let's study what are the heat changes associated with chemical reaction. Let's do an activity to check whether there is a heat change during a chemical reaction. Right. For this, let's take two beakers, a thermometer, and a glass rod, and two chemical substances, sodium hydroxide and ammonium chloride. First of all, let's take a beaker, add half full of water to a beaker, measure the temperature and note it down. And then add a little amount of sodium hydroxide solid into it, stir with glass rod, and again measure and record the temperature. The same thing, do it with ammonium chloride. Take another beaker, fill half of it with water, measure the temperature, write it down, and again add ammonium chloride solid into that, dissolve it well with a glass rod, and then measure the temperature. Right. So what might happen? What would be the reading before and after adding these two, sodium hydroxide and ammonium chloride? As if you do this experiment in your laboratory, you can see when you add sodium hydroxide, the temperature increases. But when you add ammonium chloride into this water, you can see the temperature decreases. So, what is the reason for the increase and decrease in temperature? Let's see. Now, here you can see when you add sodium hydroxide into water, during the reaction, it loses heat. So, the temperature increases. But here, when you add ammonium chloride into water, there is a decrease in temperature. So that means there is an absorption of heat. Right. So to learn further about heat changes, let's do another activity. So you can see temperature is a measure of kinetic energy. During a chemical reaction, the elements in the substances, they move. So there is a kinetic energy. So by temperature, we measure it. And heat is the transfer of energy from one object to another. So you know the law of conservation of energy. You have studied it from grade 6. Energy is neither created or destroyed. It changes from one form to another form. For example, when you switch on a fan, the electrical energy changes into kinetic energy. So in the same way, it happens here. During a chemical reaction, as I told you earlier, the making and breaking of chemical bonds either absorb or release energy. So during every chemical reaction, a heat change occurs. To learn further about heat change, let's do another activity. Activity 8.2. So here, take a test tube and add sulfuric acid into it. Before adding magnesium ribbon, measure the temperature of sulfuric acid and then add a magnesium ribbon. See what happens. What would be your observation? Right. So when you add magnesium ribbon into hydrochloric acid, there would be, you can see gas bubbles rises in the test tube. Also, you can see the temperature increase. So that means heat is lost there. So the chemical reaction happening with the evolution of heat is called exothermic reaction. Remember the word exothermic? When the heat is lost, when a chemical reaction takes place where the heat is lost, we call it exothermic reaction. Right. So here, this reaction, chemical reaction, can be represented as follows: reactants, arrow, products, and heat. So what is a reactant? Reactant is a substance taking part in a chemical. Also, the product is the new substance which is formed by a chemical reaction. So always we write it this way. And here the heat also a product. So we write it with the product. So here you can see the chemical formula of chemical equation of this reaction. Magnesium solid react with hydrochloric aqueous, and the products are magnesium chloride aqueous and hydrogen gas. Also, since it releases heat, we add heat here. Right. So what is exothermic reaction? When during exothermic reaction, it releases heat. So the energy is released. Therefore, the product has less energy than the reactant. So we can illustrate the exothermic reaction by using an energy level diagram as this. So here you can see the reactant and the product. Here, the product has less energy than the reactant. Reactant has high energy and the product has less energy. Why? Because the energy is released. So you can see when a chemical reaction is given, you can point it out as this. The reactants we use here, magnesium solid, hydrochloric acid, and the products, magnesium chloride and H2. Right. So let's do another activity. Right. Here we use baking soda and citric acid. When you add baking soda into citric acid, what would happen? Right. So here, when sodium bicarbonate reacts with citric acid, you can see the temperature decreases. So that means in this reaction, it absorbs heat. So that's why the temperature is decreasing. The reaction taking place with the absorption of heat is called endothermic reaction. So how do we write it? Here, with the reactants, we add heat. Why? Because the reactant absorbs heat and the product is formed. So what is an endothermic reaction? During a chemical reaction, when there is a decrease in temperature, that means when it absorbs heat, that is called endothermic reaction. Also, we can see During an endothermic reaction, a chemical bond is formed to store heat as energy. Here, in the endothermic reaction, if you see in this energy level diagram, the product has much energy than the reactant. Why? Here, the reactant has less energy than the product. Right. So you can write it this as well. Here you can see the reactants, sodium bicarbonate and citric acid, also the products, carbon dioxide, water, and a new substance which is formed during a chemical reaction with sodium bicarbonate and citric acid. Right. So how do we measure how much energy is lost or absorbed during a chemical reaction? Right. So let's do this experiment to find out energy change quantitatively during a chemical reaction. For this experiment, we are taking sodium hydroxide solution and hydrochloric acid solution with same concentration. Here we are using 2 mole decimeter minus 3 sodium hydroxide and again same concentration hydrochloric acid with same volume. We are taking 50 centimeter cube of each, right? And then first of all, we measure the temperature by using a thermometer. We measure the temperature of these two and then we add these two together and stir it well. Here I have given a clear diagram of this. Here we have attached a thermometer and a glass stirrer. And here we are using a polystyrene cup, right? I'll tell you the reason later. Right. So the chemical reaction take place here is when hydrochloric acid react with sodium hydroxide, it forms sodium chloride and water. Right. So by using a thermometer, we can measure the temperature. But why do we use polystyrene here? As you see, polystyrene is an insulator, so it prevents heat exchanges. So during the experiment, you can see when the chemical reaction take place, it can absorb heat from the outside, from the environment, or during the reaction, it can release the heat to the environment. So to prevent that, only we use polystyrene here. We use thermometer to measure the temperature and we use a glass rod to maintain the temperature approximately over the solution. Right. During this experiment, we take few assumptions. One is the density of the solution is equal to that of water. Here, since we use dilute solution, it is taken as the density of the solution is equal to water. Here, earlier, when we measured the temperature of hydrochloric acid and sodium hydroxide, most of the time, both are in room temperature. But if you see any temperature difference, you can take the mean value of both temperature. And the second assumption, the specific heat capacity of the solution is equal to that of water. And the third one, there is no zero heat loss, right? So here, to measure the heat change during the chemical reaction, we use this formula. Q equals mc theta, right? So Q is the heat change, m is the mass of the substance, and C is the specific heat capacity of the substance, and theta is the temperature change. Right. So let's see. The specific heat capacity of water is 4,200 joule kilogram minus 1 Celsius minus 1. The density of water is 1 gram centimeter minus 3. So the mass of 100 centimeter cube of water is 100 grams. We multiply it by 100. And then let's assume that the observed temperature change in the experiment is 10 degrees Celsius. If it is, apply that in this formula, Q equals mc theta. And you can see to convert this 100 grams into kilogram, we have divided it by 1000. And this is the heat capacity, and this is the temperature change. When we multiply all these, you can get the answer 4,200 joules. Right. So, end of this lesson, we should know what is exothermic and endothermic reaction. Before that, you should know during a chemical reaction, there is a heat change. If it loses heat, it releases, the temperature increases, so that means it releases heat. We call it exothermic reaction. So these exothermic and endothermic reactions are important in various activity in our day-to-day life. One is burning fuels. Right, so we need energy for so much of activities when we cook or to drive a vehicle or the machines we use in the factories, or everything need energy. So by using these, by burning these fuels, and we can get energy. From that energy, the machines work. Right. So we use exothermic reaction there. So burning fuels, combustion of fuels, neutralization reaction. When acid react with base, that we call neutralization reaction. So in that one also it releases energy. So we call it exothermic reaction. And cellular respiration. And the next one, production of slaked lime. When we add slaked lime into water, it produces calcium hydroxide. So endothermic reaction, during endothermic reaction, the temperature decreases. That means it gets cold, so it absorbs heat. So we call it endothermic reaction. For example, you can see photosynthesis, thermal decomposition of many chemical compounds, production of quicklime by burning limestone. You can see the chemical equation here. Right. So in this lesson, you must understand three things clearly. One is that the heat changes take place, what is exothermic and what is endothermic. You should know if a reaction is given, you should know to identify whether it is exothermic or endothermic. If it is so, you should know to prove it in an energy level diagram. And finally, if you are asked to find the heat changes quantitatively, remember the equation Q equals mc theta. M is the mass, C is the heat capacity, and theta is the temperature change. So when you apply that in that formula, you'll be able to find the answer. Thank you for listening.